Welcome back to the first section of Chapter 9. In this chapter, we're going to be looking at how to solve quadratic equations. We've looked at what they are, we've looked at the quadratic functions and the graphs, so now we're looking at solving. We'll be taking it little bit by little bit. Today we're going to be focused on solving these quadratic equations using tables and graphs. So, our learning targets, I can use graphs and tables to find solutions of quadratic equations. All right. Now, so the first question is, what are solutions? Like when we're solving, what does that mean? Well, we have a couple synonyms here. We have solutions, we have zeros, we have x-intercepts, and we have roots. These all mean the same thing. In certain situations, one of them will make more sense to use than the other, but in essence, they're all the same thing. These are all the solutions. And what they are, when we have a quadratic function, is they're these points right here. It's where the x-intercepts are, they cross the x-axis. That's what we're going to be looking for. So again, today we're going to be using tables and graphs to find these. In the next couple sections, we'll be doing it algebraically. So, using graphs. If we have a graph, if we have a function f of x equals x squared minus 16, that's a function. What we're finding is specifically 0 equals x squared minus 16. That would be the quadratic equation. So we can graph it using technology probably to graph. And we're looking for these intersection points. And so if we look, it's on the second box here, but notice it goes to 10, so these are counting by 2's. So this would be at x equals negative 4 and at x equals 4. So we have two solutions here. Notice it's very possible to have two solutions. And it's not always just positive and negative of the same number as well, which we'll see. So let's take another one. F of x equals x squared minus 14x plus 49. So this is how we would graph it, but really we're finding 0 equals x squared minus 14x plus 49. So when we graph it, f of x equals x squared, we get this, which here we only have one solution at x equals 7. So when the vertex is on the x-axis, when the vertex is the solution, there's only one solution. The first example, we had two solutions. Well, is there another option? Here we have f of x equals x squared plus 3x plus 7, which would be 0 equals x squared plus 3x plus 7. But when we graph it again, f of x, we get the graph and it's up here, and notice we have nothing down here by the x-axis. The minimum value it gets to is right there, so it never hits y equals 0. So in this case, we have no solutions. And depending on the problem, no solutions actually has a lot of different applications to it. It is possible that it just doesn't happen. So that's what it looks like graphically, is it's either completely above the x-axis opening up, or it'll be completely below the x-axis opening down. So again, using graphs, we graph it, and then we find those points where it crosses the x-axis. All right, how about solutions using tables? So we have x squared minus 7x plus 6. We're going to see how you can use a table. Now you could do this in a graphing calculator, but again, a lot of you don't have graphing calculators readily available, so we'll look at it using Desmos. Here I have, it's not just the graph, we have the whole thing. So the first thing we're going to do is we're going to type in f of x equals x squared minus 7x plus 6, because we have to type in the equation. And now we're going to go up to the table. We're going to enter a table. We're going to change that y2 into f of x1. And then as we see, x equals 1 looks like our first one. So let's go 0, 1, 2, 3, 4, 5, 6, 7. And now we're looking for when y equals 0. So notice y equals 0 down here when x equals 6, and y also equals 0 up here when x equals 1. So our solutions here, we've got x equals 1 and x equals 6 because it hits twice. Once is on the graph. The other time is going to be just to the right of where our viewing window is. But we were still able to find it in the table. Again, we're looking to see when does y equal 0. Well, sometimes that works better than others. Here, if we have 3x squared plus 5x minus 2 equals 0, we can graph this. We'll type it in. F of x equals 3x squared plus 5x minus 2. And so we have a couple. We're going to put in a table. Oops, that's not right. Let's close that one. The plus sign, table. We're going to put in a table, change the y1 to f of x1. It went above my function, that's okay. And now here we can see one of our points is at -2. So let's start a little bit before that. -3, -2, -1, 0, 1, 2. And now we see that in between 0 and 1, it goes from a negative number to a positive number. It's going to hit 0 in between there. So let's try a few extra points, 0.25, 0.5, 0.75. So now that's zoomed in there, we can see it happens in between 0.25 and 0.5. So between a quarter and a half. And we could keep zooming in, or maybe we'll just have to estimate. So we know it happens at -2. And then also somewhere between 0.25 and 0.5. Now, if you look at 0.25, it's actually pretty close to 0. So my guess, one of them, we have x equals -2. And then this one will be probably about, x is about 0.3-ish. We could zoom in further, but it looks like it's going to be about there. In the next couple topics, we'll see how to find those values exactly and not have to rely just on the graphs and tables. So let's do another one. So Anastasia hits her golf ball off the tee. The height of the golf ball is modeled by the function f of x equals -5x squared plus 25x plus 1, where x is the number of seconds after the golf ball is hit. How long is the golf ball in the air? So we're looking at the x value for how long it's in the air. Now, it's going to be in the air until it hits the ground. When does it hit the ground? It hits the ground when this equals 0. So when f of x equals 0, it's on the ground. So this is just the same thing we've been doing. We're going to graph this, and we're going to see when it equals 0. So we graph it, we see that it's going to equal 0 here at negative something. That doesn't make sense. We didn't have negative time. Remember, it's sitting on the t, and so if, like, the second you hit it, if you went back just a little bit, it would have been on the ground, but it wasn't. It started on the t. So anything before the y-axis here doesn't make sense in the problem. So we hit it, the ball goes up, it comes back down, and it lands right here, and that is at x equals 5. So we have x equals 5. So how long was the golf ball in the air? From 0 seconds to 5 seconds, so for 5 seconds. Now, this doesn't tell us how far it went or anything like that. We can get the maximum height if we wanted to. And that's what we were doing last chapter. Right now, though, we're focused on when it hits the axis. So that's what we're looking at, graphs and tables, looking for those x-intercepts. I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.